we'll touch upon some of the basics of this collection. So first is about the when we are creating the stack, right? When we are creating the stack, we are creating and we are putting as like data type as an integer, and it cannot accept the primitive data type. It accept only the generics, and all these are basically a classes. This integer is a class, and this is actually a keyword, right? So this is a class which is basically having as a base class. For all these, the base class is an object class, right? And this accepts the this does not accept the primitive, and this is basically generic. We can also do something like this. Still, it does not give any compilation error. You put anything on this object, a complex object, primitive type, but we may get a runtime exception because we don't know what is the type of this. Maybe we can check the type of it before doing the casting. That also we can do to avoid any runtime exception. Okay. So, but basically in this specific scenario, in this function, right? So we know this is an integer in this function, and we are creating the stack for object. It would be the integer always. We are putting into the stack and we are popping it out. In this specific scenario, right, we can say that the runtime exception, those will be avoided. But here we are talking about the performance of the system. So it has to do the casting, right, from object to an integer, and then from again an integer to an object for printing, right? So basically we are doing a casting and upcasting and downcasting here. That upcasting and downcasting is basically when we convert from long to integer and integer to long, where we basically the memory wise we are doing upcasting and downcasting. Here we are doing casting from object to integer all the time. So there are two major problem here. Is one is about the performance of the system. We are doing casting, we are basically typecasting it from one type to other type. Second time we are exposing as a runtime exception. So if we don't know what is the type of it, and we are expecting some different type, and it is in another type, so it will throw an exception. That is one. Okay. Second, what we see from this is a shortcut for creating the for loop here, right? And then we can create a for loop with something like this as well. For int I is equals to 0, I less than nums dot length, and then size and I plus plus. And here we can have nums dot get I. As we have seen in our last session, when we are doing this nums dot get and we pass this integer, it is going to take that as an index. So we can see here when we are writing a get here, right? So it is a primitive type here, int. And when we give this int as I, it is taking as an index. So we are saying for this particular index, give me the number which it contains. And there is a three major function, I would say, that you always remember for most of these data structure, right? One is common, basically stack is empty. This is empty function that is derived in the base class. So this is empty function is available on majorly all the collections, which we will see now, whether it's a stack, queue, priority queues, which is a min heap and max heap we'll talk about now. uh, okay, and then there is a push and pop. Similarly with push, we are pushing into the stack and we are popping from the stack. Similarly for the queue, there is a offer and pull. So right, so you need to remember these functions once you understand the concept for this function, how it works internally, which we have seen our last session, and now we are trying to do more practical. I see most of the time, right, when we get into it, many candidate I see that when they start writing, they just say that I don't remember the function for it, but I know there is something called push, pop, in queue, dq for the queue. But I would say let's keep it in our habit of keep writing the code and remembering this function so that we don't forget it. Otherwise it will be difficult, right, when you're gonna appear for the interview, and then you're gonna revise each and everything. So let's in a habit of remembering this function. So yeah, I hope all of us have completed this exercise. One more exercise, similar exercise we wanted to do for the queue. So in case of queue, once we are getting this list of integers in our function, we are inserting in the queue, it is going to insert into the same order. And when we are gonna pull from the queue, right, we are gonna pull one element at a time, and then we are gonna print this number. So it will be printed into the same order, like 5, 9162. So let's do this exercise quickly to get hands-on on the queue before we get into another problem with the data structure and algorithm. Let me replace this. And queue, as we know that for the queue there is no concrete class, so it's a linked list. So as we see here, right, the queue is in an interface. In this case, stack was a concrete class, as you can see, right? But queue is not a concrete class. In this case, it's an interface, and there is no specific implementation of the queue in Java. As we know, all of are working on Java. uh, there are slight variation between different languages, but if you talk about specific to Java, there is no concrete implementation specific to queue, and that's why we are using a linked list here. Okay, so linked list and this queue is an interface. To give a more styling and standardization, we are using queue. We can use linked list as well here. It does not make any difference. Okay, so this linked list we use because that's the same thing. It's just a different name. Now here, if you see, this is a queue. Now the question is, when should we use queue and when should we use linked list here? So queue we should use when we need a basic functionality for offer and poll, which is our use case, where we just wanted to poll from the from the beginning and keep on adding offering from the end. So that in that use case, let's use a queue, which make standardization that anyways we do not need any more functionality in this function. And if any developer is going through and reading a code about this is now talking about the more readability of the function. So whoever is reading the code, as soon as we see a queue, then we know what all functionality the code will be more readable. Okay, now if we use the linked list, as I said, it will not make any difference here, right? But at the same time, this is gonna expose few more functions. Now you will see here, remove from first, remove from last. Now remove from last, this function, that is not the functionality of the queue. This is basically going to remove the element from the end. For example, we have 2 4 9 1 3, right? So if we call this function is going to remove this 3 from here. But that's not a functionality of the queue. Queue can be removed only from the front, it cannot remove from the end. So this is a functionality of the stack, this is not the functionality of the queue. So now you would see linked list, right? In linked list use case, let me put this as an integer here. Okay, so in case of linked list, if you see, this is kind of a combination of the stack and the queue. So where any elements can be removed from the front, removed from the end, added from the front, added from the end. So when we need this functionality, right, we use a linked list here. And for the naming convention, we should always use the right naming convention. Instead of the queue, we should use the linked list here. So now the developer, whoever is reading the code, they would know that it could have another functionalities as well, right? While reading the code, that it can remove from the beginning, from the end. But one thing you would see, right? Removing from the front and end, it will always have the time complexity of O of 1, because here we are just removing, we are not changing any link here. But when we remove from the middle, we have to traverse to that node and then remove it. In that case also, for removing, the time complexity would be O of 1, but traversing to that index, that is not supported by indexing, is not supported by the linked list. Indexing is supported by the array list that we have seen in the last session. Just we need to just I want to talk about the more practical implementation and what are the benefit one over the other.